All right. Limits and derivatives, here we go. So is this your first question here? This is about the definition of derivatives, yes?
Yeah.
All right, so the way to do these problems is you literally just do substitution here. So I'll color code it so you can see. So the f of x will make that red. So I'm going to write f of x here. So it's going to be the limit. Can you see everything okay?
Yeah.
Okay, the limit as x goes to -3 of, so I'm writing f of x in. What was that, 4? See how I wrote f of x there? Minus, now I'm going to put f of 3 in here. So I'm going to substitute this in blue. So f of 3, let's do the math over here. Let's plug 3 in. That would be 6 over 9 minus 4, which is 6/5, right?
Yeah.
Got that? And that's all over x plus 3. So now we have to do some manipulations to try to simplify this. First of all, let me point out that if you tried to plug in -3 at the beginning, you would have gotten 0 over 0. If I plug -3 in here, I would get 0 over 0, right? Which is indeterminate. So that means I should be able to simplify it in some other way. So the way I'm going to simplify this is I'm going to multiply the top and bottom by the least common denominator of the tops and the bottoms. I don't know if your teacher does it this way or not, but I really prefer it this way. Makes the world much easier. So what I'm doing is I'm multiplying this here and here, and I'm just multiplying it here. When I multiply it here, what's going to cancel out?
The x squared minus 4.
And you'll just have what left over? You'll have a 5 and a 2x multiplied together, right?
Oh yeah, so 10x.
Which is what?
10x.
Good, 10x. And what happens when I multiply this here? What cancels out?
The 5.
The 5s cancel out, and you just get, now we'll make sure we keep that negative. -6 times x squared minus 4. Right? And then on the denominator, I'm just going to leave everything. I'm not going to multiply it out. I'm just going to leave it like this. Okay, you see how I did that so far?
Yeah.
Okay, do you have a question of what I did? That's called clearing the fraction, basically. Whenever you have a compound fraction, a big fraction with fractions inside it, that's a trick. You can multiply by the least common denominator of the numerator and the denominator. So that's this times this. But you have to multiply it on the top and the bottom, right? Because you have to preserve the integrity of that fraction. It's kind of like multiplying 1/2 by 2 over 2 and you'll get 2/4. You understand what I'm saying?
Yeah.
And the reason I do that is because now see how I don't have a complex fraction anymore. It's just I have a numerator and a denominator. So when I simplify this, I'll do that down here. The limit as x goes to -3 of, I'm going to put this in general form to standard form. I'm going to put the x squared in front. So -6x squared plus 10x, what, plus 24?
Yeah.
Plus 24, get that?
Yeah.
All over 5 times x plus 3 times x squared minus 4. Now I'm going to, what can I factor out of this? Are you good at factoring?
Out of the top, you could take a 2-way.
Yep. And let's take a -2 out so that we have a leading coefficient of a positive leading coefficient, just always easier. So this would be 3x squared minus 5x minus 12. right? And what do you guess is going to factor out of this? Just take a wild guess. Well, you should know. Which of these factors at the bottom is going to also be a factor on the top?
Would it be the x squared minus 4?
Nope, it's going to be x plus 3. You want to know how I know that?
No.
Because at the beginning, when I plugged in -3 in the top and the bottom, I got a I got a 0 over a 0, which told me that it was very likely that x plus 3 was a factor of the top and the bottom.
Oh.
You remember that with removable discontinuity when you were doing that with functions or with rational functions?
Yeah.
So that just helps me factor it. I know there's going to be an x plus 3. So the other one, if this is an x, that has to be a 3x right there. You follow?
Yeah.
And if this is a 3, a positive 3, what has to be right here in order for it to be a -12?
A negative
A negative what?
4.
A -4. Now let's see if we did that right, because now it's starting to look like that didn't work. We must have made a mistake, because this actually gives you a positive 5x, not a negative 5x. So we made a mistake somewhere. Hopefully it was just with the sign or something. It was with the sign. Nope, it wasn't, because I factored out a negative. So this should have been there should have been a positive 3 in here. I'm sorry, an x plus 3, not an x minus 3. But if I factored this correctly, it would not be that. So what's wrong? Let's go back and see if I plugged something in wrong. This is the other part of these problems. There's so much tediousness in here. You have to be really careful that you didn't make a mistake. Did you see a mistake that I made somewhere?
I'm not sure.
Let's go back. -3, that's a negative. Oh, is that the problem? Yeah, should this be a -6 over 5? Should that be -6/5? I think it should be. Because then I plug in a -3, I get a -6 over 5. Yeah, that was my mistake. So it's a -6/5. So this would actually be a positive right here, which means this is a positive right here, which means this was a positive right here, and -24, and 24 was a negative. There's my mistake. We can still take a 2 out, but now I'm going to have a positive and a negative. Aha. And now this is how it factors. That was an easy fix. You see the mistake that I made?
Yeah.
Okay. And so, yes, this does cancel. So I can cancel that, and that. So this basically just equals the limit as x goes to -3 of 2 times 3x minus 4 all over 5 times x squared minus 4. And now, can I plug in the -3?
Yeah.
I can now. If I plug in -3 here and here, I get, let's see, what's that? -9 minus 4 is -13. So -26, stop me if I'm wrong, all over -3 squared is 9, +9 minus 4 is 5, 5 times 5 is 25. -26 over 25.
Oh, right.
Do you have the answer key with you by chance?
We did not get one.
Okay. Well, I'm pretty sure that's true, but the way I can check it is I know the shortcut for derivatives. The shortcut for derivatives is the derivative is going to be low times the derivative of the high minus high times the derivative of the low all over low squared. So if I plug in -3 to this, I should get that same answer. So it's 2 times 5 minus -3 is -6 times -6 all over 30, no, sorry, 9 minus 4 is 5 squared, 25. This is 10 minus 36, which is -26 over 25. Yep, that's right. This is something you'll learn later in calculus. This is using derivatives. So the way you're doing it right now is this is a long form. This is a long cut. What I just did here is the shortcut, which you'll learn soon. Questions about that, or can I go to the next one?
That one made sense.
Okay, so this one it's the same definition. It's the same kind of definition. It's a limit, but it's written in a slightly different way. You could either write it like this, f of x minus f of a over x minus a, or you can write it as the limit as f of x plus h minus f. You see how this is a y minus a y on the top?
Yeah.
You see how before it was a y minus f of x is like your y minus y over x minus x. Does that remind you of anything? Y minus y over x minus x, what's that called?
Like the slope one.
Yeah, that's slope. So that's basically what these things are. These things are slopes. What you're basically finding is the slope of the tangent line of this particular equation at every point.
Oh.
So, and I'll explain that further with this last one we just did. The tangent, this right here, if we graph that, 2x over, let's graph that real quick. Can you see my graph here?
Yeah.
2x divided by, whoops, that's not an x. 2x divided by x squared minus 4. X squared minus 4. If I graph that, that's a rational function, right? But look at -3. At -3, do you see -3 right there?
Yeah.
What is the slope? If you were to put a line on that, or a tangent line at that point right there, imagine a tangent line. You can actually kind of see it. You see how that purple line, you see how there's like the purple horizontal line right there? That's the tangent line.
Oh.
Do you see? That tangent line has a slope of -26 over 25. That's what this does. So that line right there, the tangent line at that point, -1 or -2.25, sorry, -2.25. The slope of that tangent line is negative, I don't know, -1 maybe. Something close there. See that slope of that tangent line is a negative, it's a bigger negative number. You see what I'm talking about? That's what these things are doing for you. So this equation, when I find this equation right here, that's going to be a generic equation for the slope of any tangent line of this particular graph. So let's just remember that before I do it. Then when I do it, we'll go back and I'll explain it because I'm sure it's coming up soon anyway. So let's do that again. What is f of x plus h? Well, that just means I'm plugging. So I'm finding the limit. I'm finding the limit as h goes to 0 of, now I'm going to do red, I'm going to color code it. F of x plus h means I'm plugging in x plus h into f of x. Everywhere I see an x, I'm plugging x plus h in. Got it?
Yeah.
And then I'm subtracting f of x. So what's f of x? Use parentheses, it's negative 2x squared plus x. That's f of x. And then I'm dividing that whole thing by h. So when I simplify this out, that's going to be the limit as h goes to 0 of, what is this multiplied out to? Do you know how to do that quickly?
X squared plus h squared plus xh, right?
Yeah, x squared plus 2xh plus h squared. Yep, good. So I'm going to write that here, negative 2x squared plus, minus 4xh, stop me if I make a mistake, minus 2h squared. Now I'm going to write this there, plus x plus h. And now I'm going to distribute that negative in. That will give me positive 2x squared and then negative h all over h. Okay. And if I did this right, things are going to cancel out. The x's cancel out. The 2x squareds and the negative 2x squared cancel out. And I'll be left just with things that have h in it. Why is that so important? Well, because then I can factor the h out of all those things. And I have negative 4x minus 2h plus 1 left over, all over h. Do you see what I did there?
Yeah.
I factored an h out of each one of these three. Don't forget that plus 1 there. It's very important. And now the h's cancel, which means this is the limit as h goes to 0 of negative 4x minus 2h plus 1. And what happens as h goes to 0? What does this thing turn into? What happens to that thing? What happens to negative 2 times h if h is going to 0? That gets closer and closer to 0.
Yeah.
You understand that?
Yeah.
That's what this means. That means find the limit as h gets closer and closer to 0. Well, will as h gets closer to 0, will this term be affected? Is there any h in that term?
No.
No. What will happen to this term? It gets closer to 0. And what about this term? Will that be affected?
No.
No. So what is the answer? Negative 4x plus 1. That's your answer. And again, here's what that means. So this is called the derivative. The derivative equals negative 4x plus 1, which tells you the slope of the tangent line of f of x at every x. That's what that tells you. The slope of the tangent line. Got it? So let's see what happens. Let's graph the original function. Are you following what I'm saying right now?
Yeah.
Okay, here's the original function. There's the graph. Do you see? Pick a point, any point, like between negative 2 and 2. Give me a point.
2, negative 5.
So you said 2?
Yeah.
Okay, so there's 2. Well, it's close to 2. It's not quite at 2. Pretty close to 2. You see that tangent line, that purple line, that horizontal line that's running along the graph? You understand what I mean by that? Tangent line?
Yeah.
What is that? What is the slope of that? Give me an estimate. What do you think the slope is of that line? First of all, is it positive or negative?
The purple one?
Yeah, the purple one that's going down from left to right.
It's positive, right?
Well, the one going up from left to right is positive, but that one is doing this. Here's the graph. It's going like this. The tangent line I'm talking about is this line right here. That's the tangent line.
So negative.
You see how that's a negative tangent line?
Yeah.
So what happens if I plug in f, what's f prime or the derivative at 2, plug it in to that equation, what are you going to get?
If you put in 2.
You're plugging 2 in, yep. What are you going to get?
-7.
That's the slope of that line.
Oh, so you can use this one for anything.
Yep, no. So there's 2 right there, right? If I zoom, the reason it didn't look like that is because I wasn't zoomed square. I wasn't square zoom. If I zoom so it's a square, that's more like a square right there. Then you could see it and it looks more like -7, right? The slope of that line right there, of the horizontal line that's on that, is like a negative. That's the slope of -7. That's what these things do. That's what the derivative does. The derivative gives you the slope of the tangent line of this graph. So we were just looking at this graph, but we were plugging a point into this formula, and this formula gives you the slope of the tangent line at every point on the graph. That make sense? Kind of? Okay, because you're going to get to that. Like I said, you're going to get to that soon. So again, what's the limit as x goes to 3, -3? Well, this is a different kind of a problem. This is just a rational function. Remember, you just finished rational functions.
Yeah.
So you can't plug in -3 because it gives you 0 over 0. And that means that x plus 3 is a factor of the top. And if x plus 3 is one of the factors, what's the other factor?
X minus 2.
Good. And that didn't work, so I lied. The limit as x goes to -3 of this, you actually don't get negative. You don't get 0 on the top, do you? No, you don't. So the limit of this, I take that back. This is a vertical asymptote then. So instead, you're wanting to plug in as x goes to -3. What is the y value getting closer and closer to?
0.
Well, there's a vertical asymptote, right? At -3. So it's either going to be a positive infinity or a negative infinity, or it's going to not exist. And in this case, it's going to not exist. Okay, I was just talking to Meher. Is it Meher?
Meher, yeah.
Meher, sorry. She didn't. I guess your teacher didn't teach you about the multiplicity trick when you're trying to figure out asymptotes.
No.
Okay, so let's just graph this. Do you mind if I graph this one? This is a this is a rational function, and it's going to have a vertical asymptote. It's going to have this does not factor like this on the top. So sorry. In fact, it doesn't factor at all on the top, does it? Doesn't look like it. 3 and 2. No, it doesn't factor at all. So the x-intercepts are going to be you'd have to use or quadratic formula to find them. I'm not going to bother with that. It's going to have a slant asymptote. If I do long division, polynomial long division, it'll have a slant asymptote. Well, I'm not going to bother doing this. I'm just going to tell you that the VASI is going, because this has a multiplicity 1, there's the factor of x plus 3 has multiplicity 1 because it's to the first power, right? It's not raised to the second power. That means that the asymptote has to be approached from opposite directions.
Oh,
Get that?
yeah.
So it's either going to be approached this way and this way, or it's going to be approached from the right going up and from the left going down. That's what happens when the multiplicity of that factor is odd. If the multiplicity was even, if this was squared, then they would both be approaching the same direction. So if that was the case, we'd have to do more work because there might be a limit. But since that's not the case, since it's odd, I know that the multiplicity, I know that the answer to this does not exist. There's no limit because it approaches it from opposite directions. Got it?
Yeah.
All right. I'm going to go to this next one. Do you know the trick to finding this?
No.
Okay, so this one, I know it looks like the same kind of problem, totally different. This one doesn't factor. When I plug in -3 on the top, I don't get 0. I get it on the bottom, but I don't get it on the top. That means it's a vertical asymptote. Okay.
Yeah.
This one, when I plug -3 in on the top and the bottom, I get 0 over 0. That means that it's a RD. It's a removable discontinuity, which means there is a limit. And the way to do this is you multiply it by the conjugate. Do you remember doing this in class?
Yeah.
So this is the conjugate. When I multiply that into here on the top, the square root will go away. You have a -4. And when I multiply it on the bottom, just leave it. When I do that, this is x plus 3. That means this cancels. So I get 1 over the square root of x plus 7 plus 2. And it's the limit as x goes to -3. And now I can plug in -3, which equals 1 over 4. I know I did that fast, but do you see that?
Yeah.
Got how I do that? How I did that?
Yeah.
Okay, for this one, what you'll notice is that this is another similar to, this is different than the last two that we did. But this one, if you'll notice that when you plug in -2, you get 0 over 0. But what will happen when you have this is if you make a T-chart and you plug in some points, so this doesn't exist, you can't plug that in. But if you plug in -1 and 0, you'll notice when you plug in -1, you're going to get a +1 on the top and a +1 on the bottom. What's 1 over 1?
1.
It's 1. When you plug in a 0 on the top and the 0 on the bottom, you get what? +2 over +2, which is 1. Everything that you plug in to the right of -2, no matter what you plug in to the right, you're going to get a +1 out. But then when you plug in negative numbers, numbers to the left, plug in -3, what's the difference? If I plug in -3, the top is still going to be a positive, but what's the bottom going to be?
Negative.
It's going to be a negative, which means you're going to get a -1. If you plug in -4, you'll get a +2 on the top, but you'll get a -2 on the bottom, which means you'll get a -1 again. If you plug in -5, you get a +3 over a -3, which is -1. So down on the bottom, it goes like that. So what's the limit as it comes from the right? That's this way. What's the limit as it comes from the right? It's +1. What would the limit have been if it came from the left?
-2.
It would have been -1. The limit as x goes to -2 from the left of that same function. Do you see it here? If you came from the
Oh,
left, it's -1. Okay.
yeah.
All right. I think our time is up.
Oh, yeah.
So you can also check this video out on YouTube.